Okay, so today we're going to be exploring watersheds, and in order to do that, we're going to create a personal geodatabase to keep things organized, and we're going to call it watershed. And well, I also created a data folder that I'm going to keep everything organized. So let's create a toolbox while we're at it, and we'll call that watershed, as we'll be using Model Builder to make our life easier. Okay, inside Watershed, we are going to need a new model, but first let's explore our, I've downloaded 4 DEMs, and this is what we're going to be using to do a mosaic raster. So let's go to Explore. Immediately we can see the cell size, and it's a signed integer, which means that it can hold negative and positive values, and it's a 16-bit integer. So with that being said, and let's get started, but it is also in decimal degrees, so we need to make sure that our coordinate system is not going to be affected as we're outputting our stuff. So let's set our current data or workspace to our data folder and our Scratch workspace to our data folder. We'll also set our coordinate system to a continental Africa Lambert conformal conic, as this is where the coordinate system in meters for Africa, and that's what we're going to be using to process this. So that being said, let's get started with our model. So we'll right click, new model, and we'll go ahead and go into the data management tools and go to raster, mosaic to new raster. And if you click over here in your catalog, you can just drag in the DEMs that we're going to be using. Another cool thing that you can do is you can just drag in your data folder, and you can specify all of your input rasters, and you can specify this as your output location. And now that we have our tool set up, let's go and name it. So this is going to be Awasa DEM, and let's match our properties from our other image. So there's one band since it's elevation, and we're going to use the last operator, which is going to output the last value of the, so if this one was first and this one was second, the value from this one is going to be kept when it merges them. So let's go ahead and run our model. So I must have not put the correct I forgot to add TIFF, so apply and OK. Now we can run it. Okay, so what we've just created is a merged DEM, and the model is fine, but there are some artifacts that you can explore, and I'll show you how to explore your artifacts. Okay, so first let's add in our DEM that we just created, and here is our merged DEM. The next step to exploring our data is to do, I'm going to build a new model, and I am going to add in my DEM, but I'm also going to go down to spatial analysis tools, and I'm going to do my hydrology, and I'm going to create a fill, which is going to basically everywhere where there's water is going to create funky values, and in the bottom of valleys it's going to create funky valleys. So I want to fill in the information and make it more manageable so there's not big bubbles. So that's what a fill does, and you can name the output as fill.tiff. Okay, you can also add a z-limit, which will make it so if your data set is pretty wonky and has a lot going on with it, then you can set how much it actually simplifies it. So let's go ahead and hit OK, and we'll go ahead and run this. Okay, so our fill has finished, and we'll add that in, build its nearest neighbors. So this is our fill, and a quick way to explore what our fill did is you can set it with the effects toolbar, and you can drag left and right to see what it did as far as removing artifacts. So let's zoom in. You can see that it's removed some of these artifacts here. One quick way to be able to visualize everything easier is to create a hillshade, and let's apply a 2 for a gamma stretch. This will make our values a lot easier to see, so we'll do that to both of them. So we'll create a hillshade and a gamma stretch of 2. This will really highlight the valleys here and the trenching, so let's go ahead, and now you can really see the difference between our fill is the top layer. Right now you can see it going over. So right here there's a lake, and you can see how much of the lake has been filled in. So these are very high or very low negative values, or high negative values, and they've been filled in. So that's what a fill does. And that's why it's also important to run so your data isn't thrown off. Okay, so that is kind of meaningless to just visually inspect it. So let's go ahead and do some map algebra or raster calculator, and we'll go ahead and put our fill in here, and we'll also put our first DEM, and we'll subtract our fill from there. So every cell will have a value minus the fill value, and we'll get high negative values will be the meaning that the original DEM had a lower value than the fill DEM, and high positive values mean that the original DEM is bigger than the fill value. So we'll call this diff.tiff, as in a difference raster, and we'll go ahead and hit OK. So now that the tool is done running, you can see that the lake itself and the valleys are the places where it's made the most difference in our fill. So that being said, let's try and change our symbology a little. Change this to elevation and hit OK. So now this will just show graduation of what it changed. In the next video, I will show you how to run flow accumulation and direction.